the last kind of factoring. Now, well, the last kind of factoring we're going to go over before next year. Factor by grouping. Now, the way you recognize this, there are 4 terms. So the way these work, split it down the middle. Split it down the middle. Now we're going to GCF both halves separately. The GCF of the first half, you can divide both 15 and the 18 by 3. And there is an n in both. Go with the lowest power, n squared. Now remember the way that GCF factoring works. We divide, 15 divided by 3 is 5. You have 3 powers of n, you factor out 2, you got n left. N to the first. Copy the plus down. 18 divided by 3 is 6. And then you have n squared, and you factor n squared out. So there's no more n. Now, do the second side separate. Hey, you can divide both the 35 and the 42 by 7. Copying the plus down, I'm dividing out a positive 7. 35 divided by 7, 5, and plus 6. Now, the way this factoring works, the whole point behind this. On the left side, we have a factor of 5n plus 6. We do on the right side as well. Remember, factors are things that are multiplying. Both of those binomials, both of those parentheses are factors on each side of the line I drew down. So it's common to both of them. So it's a common factor. Just like we've done, we can factor it out like it's a GCF. So I take it out of both sides. I'm not going to draw those arrows every time. I'm just illustrating how this works. You only write down a GCF once. Now, what's left over becomes the other binomial. So if I factor out that 5n plus 6, on the left side, I got 3n squared left. On the right side, I have plus 7 left. And that becomes the other factor. So the way this works, when you GCF each half, you want a binomial that matches. If it matches, if it's the same side on the left side of the line as it is on the right side, that means it'll be common to both sides, so you can factor it out. Now, sometimes what people get confused at is where'd the other one go? You're factoring it like a GCF. You only write a GCF down once. 2, same idea, split it down the middle. I can divide them both by 8. And there is a in both on this side. A squared is the lower power. 56 divided by 8 is 7. You got a cubed, you factor out a squared, so you got a left. 24 divided by 8 is 3. You are factoring out all the 8s, so there's no more 8. Now, this question adds a little bit extra to think about. I got to make the binomial, like what's in the parentheses. I got to make a match. Now, on the left side, it was positive, positive. The right side, they're minuses. I gotta switch the signs so they'll match. I can divide those both by 7, but I'm gonna divide by -7 as my GCF instead. That way, when you divide 49, -49 divided by -7, switches it to positive. -21 divided by -7 switches it to +3. You gotta do that so that these match. They're both +7a plus 3. I had to divide by that -7 so that my binomials would match. Just like the last question now, factor it out. Only write it once. It's common to both, so we pull it out and only write it once, like it's a GCF. And the other, what's left over? I got 8a squared minus 7. Done. Number 3. Hey, this one's nice. Everything's positive. Left side, 7p squared. I can divide by 7 divided 7 is 1. Maybe we write the 1 down. Maybe not. There's a p left. I could write 1p, but it means the same thing, so I don't have to. 49 divided by 7, 7. All your p's are gone. On the right side, I can divide by 6. Hey, there we go. The binomials match, just like we wanted. And that's kind of a hint that you're doing this right. Now, the p plus 7s, pull that out. Only write it once. The other one, what's left over? Done. Number 4. Split it down the middle. And on this a lot, it's going to go the cube and then the square. So your GCF for the left side will have a lot of squares. Doesn't always work like that, but for these basic practice ones, it does. So we got 6m minus that whole thing divided by itself. This time I need the 1. If I don't write that 1 down, I'm missing a term. The right side, I can divide by 3. 3 divided by 3 is 1. There's no variable there, so I do need the 1 again. 6m minus 1 gets pulled out. And you got 2m squared plus 3 left. Number 5. Split it down the middle, a squared. A squared divided by itself is 1. I need that 1 because there's nothing else. And then we divide by 2. There we go. Pull that a plus 1 out. Only write it once. There you go. That one's done. Number 6. Hey, it's another one of these weird sign ones. You start them just like always. So we got 5n squared, 5n plus 7. When the signs aren't going to match, and I'll show another quick little thing here after we finish this one. Just remember, when your signs aren't going to match up, like we got a positive 5n and 7 on the left. We really don't even have much of a GCF on the right, but they're both minuses. The left is plus plus, the minus is, or excuse me, the right is minus minus. To make them match up, even though there's no GCF, I gotta divide by a negative so I can make them match. I gotta turn the right side into plus plus. If I divide by a negative, it will do that. The numbers already matched. I already have a 5 and a 7 on the right, just like I do on the left in that binomial. So, hey, what number can I divide by that won't change anything? That's a 1. Sometimes you got to divide by positive 1 if everything already matches, signs included. Anyway, you divide by -1, it doesn't change the numbers, it just changes their sign, and I got to do that so that these match. Take that matching binomial out as if it's a common factor, so you only write it once. What's left over is the other. So again, that's what's left over. Now, what I was talking about, let's say you have a question like this. I'm just making these numbers up. We're not going to do it. Well, we'll do part of it here. I don't have much room. This is what I was talking about. The left side is positive negative. The only GCF here would be x squared. The right side is negative positive. I need to switch it to plus minus so it will match the left. When I divide a 2 out, I will divide -2. That way, it switches them to match. Now, I'm not going to finish that one off. I just wanted to make sure to show you that once, at least. The binomials have to match. So if the signs on the right side are like the opposite of the left side, divide by a negative GCF to get them to match.